Hey guys, it's Danny here from Disrupt Tutoring, and as always it is a pleasure to join you. In this video we're going to do a question from the November 2018 Grade 12 Physical Sciences Paper 2. This question deals with a system in equilibrium represented by this balanced chemical equation. Dinitrogen tetroxide decomposes to nitrogen dioxide and reaches equilibrium at 325 degrees Celsius, where the final color of the gas is brown. The question tells us that initially X moles of dinitrogen tetroxide were placed in the syringe with a volume of 2 decimeters cubed, and when equilibrium is reached, it is found that 20% of the dinitrogen tetroxide has decomposed. We're then told that the equilibrium constant at 325 degrees Celsius is 0.16 and asked to calculate the value of X. So to answer this question, you need to recall the expression for the equilibrium constant, which can be written in terms of the concentration of the reactants and the products. So for this process, the expression for the equilibrium constant will be equal to the concentration of the product, which is nitrogen dioxide, raised to the power of 2 for the coefficient of 2 in the balanced equation. And that will be divided by the concentration of the dinitrogen tetroxide. Okay, so we know that this is equal to 0.16 at equilibrium, which is at 325 degrees Celsius. Now we need to find an expression for the concentration of the reactant and the product. We also have this equation relating the concentration to the number of moles and the volume of the container, which we are also given as 2 decimeters cubed. And then at equilibrium, 20% of the dinitrogen tetroxide has decomposed into nitrogen dioxide. So that means that the number of moles of dinitrogen tetroxide left at equilibrium is 80% of X, so that is 0.8. X moles of dinitrogen tetroxide. And that means that 2 moles of the dinitrogen tetroxide decompose into the nitrogen dioxide. So those are the number of moles of the reactant and the product, respectively. Now, according to the balanced equation, for every 1 mole of dinitrogen tetroxide that decomposes, 2 moles of nitrogen dioxide are produced. So that means that the number of moles of nitrogen dioxide at equilibrium is actually 0.4x moles. So from these values we can find the concentration of both the substances at equilibrium in terms of X. If we simply divide by the volume, which is equal to 2 decimeters cubed, and then we can plug those values into the equation for the equilibrium constant and solve for the value of X. So if we do that, we find that the value of X is equal to 1.6 moles. Okay, before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.